Assalamu alaikum dear students. Today it is question number 6, last question of exercise, and we are discussing lines and angles of ninth class. Lines and angles, this is our topic. Lines and angles, this is math ninth. Lines and angles, and last question of this exercise is PQ and RS are two mirrors placed parallel to each other. Now there are two mirrors. PQ is a mirror and RS is a mirror. PQ and RS are two mirrors which are placed parallel to each other. So this is a mirror. This is a polished surface, and this is a mirror. This is polished surface here. Now these two mirrors are placed parallel to each other so that PQ is parallel RS. An incident ray AB strikes the mirror. Now here it is a ray, AB is a ray. AB strikes the mirror, okay? Mirror PQ at B, the reflected ray moves along the path BC. Now that it has got reflected from like this is BC, and here it gets once more reflected. So BC is incident ray for this RS. So this is CD. Now what we have to prove is RS at point C, and again reflectors back to CD, prove that AB is parallel. We have to prove this incident ray AB is parallel to CD. This is our requirement. This we need. We have to prove that AB is parallel to CD. Now this, we know that when a ray strikes, suppose a mirror, then the angle of incidence is equal to angle of reflection. And if this is the normal, suppose this is normal, and this is another normal. So this is BL and this is CM. Now this is angle of incidence, angle 1, this is angle 2, this is angle of reflection. Again, this is angle of incidence, angle 3, and this angle 4 is angle of reflection. Now we know that the angle of incidence is equal to angle of reflection. By law of reflection, we know angle of incidence is equivalent to angle of reflection. So angle 1 is equal to angle 2, and also angle 3 is equivalent to angle 4. Now see, what is AB is the incident ray, therefore angle 1 is angle of incidence, and it gets reflected along BC. So BC, it makes angle 2 with the normal, so angle 2 is the reflected angle of reflection. Similarly, is BC is the incident ray for this mirror RS, and angle 3 becomes angle of incidence. CM is a normal, therefore, and this angle 4 is the angle of reflection. So angle of incidence is equal to angle of reflection. Angle 1 is equal to angle 2, and angle 3 is equivalent to angle 4. Now see, we know that PQ is parallel RS. This is given. PQ is parallel RS. What about this BL and CM? BL and CM are perpendiculars. Normal means they are perpendiculars. This is perpendicular. This is perpendicular. So between two parallel lines, these two lines are parallel. AB is parallel to CD, or sorry, PQ is parallel to RS, and this is one normal or perpendicular, and this is another normal. Since these two lines are parallel, and this is perpendicular 90-degree angle, this is again 90 degree, therefore these two lines are also parallel. Therefore BL, we can write here BL is perpendicular this RS, and CM is perpendicular PQ, therefore BL is parallel. These two lines are also parallel, therefore BL is parallel to CM. When BL is parallel to CM, now these two lines are like this. This is BL, BL is like this, BL, and this is CM, CM is like this, and this BC is the transversal. Therefore, this angle 2 is equivalent to angle 3. What are these angles called? These are alternate angles. You know it. Therefore, angle 2 is equivalent to angle 3. Angle 2 is equivalent to angle 3. Now see, we can write here twice angle 2 is equivalent to twice angle 3. Now twice means angle 1 is equal to angle 2. Twice means this whole angle, this angle. And I multiply just both sides by 2. This is twice angle 2 is equivalent to twice angle 3. Now twice means, since this angle is equivalent to this angle, twice means this whole angle. Angle ABC, which implies that angle ABC is equivalent to angle ACD. Angle ACD, this whole angle. But these are alternate angles. But these are alternate angles. And you know, when alternate angles are equal, what about lines? Lines are parallel. Therefore AB is parallel CD. This was to be proved. So that is it. Let me explain it further. Now PQ and RS are two mirrors which are parallel to each other. Then an incident ray AB strikes the mirror, and it is reflected along BC, and reflects and strikes the mirror RS at point C. It is then reflected back along CD. Now we have to prove that AB is parallel to CD. Now see, angle 1 is equal to angle 2. We know that angle of incidence, suppose this is a mirror, a line is an incident ray strikes it, this is the reflected ray and this is the normal, and you know angle of incidence is equal to angle of reflection. Laws of reflection, as you have read in class 9th, laws of reflection, angle of incidence is equal to angle of reflection, that is angle 1 is equal to angle 2. Similarly, since BC is the incident ray for RS and C is the reflected ray, obviously angle 3 is equal to angle 4, and this is the normal. This is called a normal. Normal means perpendicular line. So angle 3 is equal to, I write here, angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Angle of incidence is equal to angle of reflection. Now we know that PQ is parallel to RS. When two lines are parallel and two perpendiculars are there, these perpendiculars are also parallel to each other. Since BL is perpendicular to RS and CM is perpendicular to PQ, therefore BL is perpendicular. Now see, this BL is perpendicular CM, and when perpendiculars, they are parallel to each other. Therefore BL is parallel to CM. When BL is parallel to CM, what is BC? BC is a transversal. Therefore angle 2 is equal to angle 3. This angle 2 is equal to angle 3. These are called what? Alternate. Angle 2 is equal to angle 3. These are alternate angles. Now what I did here, I multiplied both sides by 2. This is twice angle 2 is equal to twice angle. What is twice angle 2 is this whole angle, because angle 1 is equal to angle 2. Twice angle means the whole angle ABC. And twice angle 3 means the whole angle, this angle BCD. When angle ABC is equal to ACD, this is not ACD, this is BCD, this is BCD. Angle BCD, but these are alternate angles. And you know, when alternate angles are equal, this is like this. This is a line, and this is another line, and this is a transversal. This is the transversal. Now this whole angle is equivalent to this angle. When this angle is 3 plus 4, this angle is ABC. And this is BCD. When this angle is equal to this angle, what are these angles? These are alternate angles. When alternate angles are equal, lines are parallel. Therefore, AB is parallel to CD. So this was the last question of the exercise. Now we shall proceed further. Now a very important question is here, a theorem. Prove that sum of angles of a triangle is equivalent to 180. So very important question. Let us prove this. Angle sum property. Sum of angles of a triangle is equivalent to 180 degree. Sum of angles of a triangle is equivalent to 180 degree. Sum of angles of a triangle is, suppose this is a triangle. Triangle, what is a triangle? Triangle, you know, this is a three-sided figure with ABC is a triangle or a polygon with three sides. It has obviously three sides, three vertices, three angles, and angle A plus angle B plus angle C is always equal to 180. Now we are going to prove this, and whether this angle 1, how angle A plus angle B plus angle C is equal to 180. It's called angle sum property. Now this, suppose this is angle 1, this is angle 2, and this is angle 3. So what is given is, given ABC is a triangle. This is a given. This is given. ABC is a triangle. Now we have to prove that. To prove sum of angles of this triangle, angle 1 plus angle 2 plus angle 3 is equal to 180. This is very important question. Now construction. Construction, we are doing one thing here. We draw a line parallel to BC. Suppose this is EF. We draw a line EF parallel to BC. Through A, we draw EF parallel to BC. Now proof. Suppose this is angle 1, 2, 3, this is angle 4, and this is angle 5. Now see, EF is a line segment, BA and CA stands on it. Therefore, angle 4 plus angle 1 plus angle 5 is equal to 180. You know it. We can write here EF is a line segment, BA and CA stands on it. Therefore, angle 4 plus angle 1 plus angle 5 is equal to 180, or we can write angle 1 plus angle 4 plus angle 5 is equal to 180. Name this equation first. Angle 1 plus angle 4. This is like this. This is a line segment, and this ray, two rays stands on it. Therefore, this angle plus this angle plus this angle is equal to 180. So this is very obvious. Now, since EF, by virtue of our construction, EF is parallel to BC. When two lines are parallel, then alternate angles are equal. Therefore, angle 4 is equal to angle 2. Therefore, angle 4 is equal to angle 2. And similarly, angle 3 is equal to angle 5. Angle 3 or angle 5 is equivalent to angle 3. These are alternate angles. Because lines are parallel by virtue of our construction. When lines are parallel, this 4 is equal to angle 2. This 5 is equal to angle 3. Now, putting the value in equation first. This is angle 1 plus angle 4. For angle 4 we write here angle 2 plus angle 5. For angle 5 we write here angle 3 is equal to 180. This was to be proved. A very important question. So sum of angles of a triangle is equal to 180. Sum of angles of a triangle is equivalent to 180. Now one more question is very important. Sum of angles of a triangle is equal to 180. Now we have proved it. Let me repeat this. ABC, this was the triangle which was given. ABC is a triangle. Now we have to prove that angle 1 plus angle 2 plus angle 3, sum of all angles of this triangle is equal to 180. This was our requirement. This was to be proved. And what we did we do construction. Construction is anything which we add in support of our proof. So we draw a line segment EF. Through A, we draw a line segment EF parallel to BC. Now, in proof, EF is a line segment and BA and CA stands on it. Therefore, these three angles, angle 4 plus angle 1 plus angle 5 is equal to 180. Just like this. This is a line segment. These two line segments stand on it. Therefore, this angle plus this angle plus this angle is equal to 180. So, I write here angle 4 plus angle 1 plus angle 5 is equal to 180. Or angle 1 plus angle 4 plus angle 5 is equal to 180. Now, see, EF is parallel to BC. When EF is parallel to BC and AB is the transversal, therefore 2 is equal to 4. 2 is equal to angle 2 is equal to angle 4. These are alternate angles. Similarly, EF is parallel to BC and this time CA is the transversal. Therefore, angle 3 is equal to angle 5. So, I write here angle 4 is equal to angle 2, angle 5 is equal to angle 3. These are alternate angles. Now, putting the value for angle 4, we write in equation first angle 1, angle 1. For angle 4, we write here angle 2 because angle 4 is equal to angle 2. And for angle 5, we write here angle 3. That is how it goes. This is angle 1 plus angle 2 plus angle 3 is equal to 180. So, this was very, very important question. Sum of angles of a triangle is equal to 180. So, you have to prove that sum of angles of a triangle is equivalent to 180. This is how it goes. Now, one more important question is, if this is a triangle, if ABC is a triangle and this side BC is produced to D, then external angle, this angle 1, this angle 2 and this angle 3. This external angle is equivalent, suppose this is equal to 4. Now, given is ABC is a triangle in which side BC is produced to D. Now, see, side BC is produced to D. When we produce this side to D, obviously an angle, external angle is formed. Now, we have to prove that. To prove this, again, very simple but very important. We have to prove that angle 4 is equal to sum of two interior angles 1 plus angle 2. Now, we have to prove that this external angle is equal to the sum of two interior angles. Angle 4 is equal to angle 1, opposite interior angles, angle 1 and angle 2. Okay. Now, proof. Now, ABC is a triangle. ABC is a triangle. Okay. We know that angle 1 plus angle 2 plus angle 3 is equal to 180. We have proved it. When ABC is a triangle, sum of angles of a triangle is equal to 180. We prove it just. This is equation number first. Now again, BD is a line. BD is a line. And AC stands on it. AC stands on it. Therefore, this BD is a line and AC stands on it. Therefore, angle 3 plus angle 4 is equal to 180. Therefore, angle 3 plus angle 4 is equal to 180. Name this equation second. Now, comparing first and second, we get this is equal to 180. The angle 3 plus 4 is again 180. So, right hand sides are equal. When right hand sides are equal, left hand sides are also equal. We can write here from first and second, we get, what do we get? Right hand side is 180, right hand side is 180, right hand sides are equal, left hand sides are also equal. What is the left hand side here? It is angle 1 plus angle 2 plus angle 3 is equal to, what is the left hand side here? It is angle 3 plus angle 4. Angle 3 cancels. Angle 1 plus angle 2 is equal to angle 4. Or you can write angle 4 is equal to angle 1 plus angle 2. So we have proved that external angle is equivalent to the sum of two anterior opposite angles of a triangle. So these two questions are very, very important questions. You will practice them at your places. And tomorrow, inshallah, we shall proceed further by probably the last exercise of this lines and angles chapter before we move on to triangles. Thanks.